Let me ask you something. Do you actually know where our solar system truly ends? Is it Neptune, the last of the big planets? Is it Pluto, way out in the cold? The honest answer is that both of them are barely the front porch. The real edge lies far, far beyond them, out at the rim of a gigantic shell of ice that wraps all the way around the entire solar system. And almost nobody ever talks about it. Today, we're taking a journey all the way out to that edge. We'll start up close, with a sea of rock tumbling between Mars and Jupiter, the asteroid belt. Then we'll ride a comet outward, past the orbit of Neptune, into the deep dark. And we'll finish at a legendary, half-mythical frozen shell that may hold trillions of icy worlds, the Oort Cloud. Trust me, the real solar system is so much bigger and stranger than the one you learned about in school. Think of these as the two great junkyards of our solar system. The inner one is a ring of rock. The outer one is a shell of ice. Both of them are enormous storehouses, packed with the leftover building blocks that never quite managed to become planets. They are, in a very real sense, the scraps left over from the day the planets were built. So sit back, and let's go all the way to the edge. Let's begin with the asteroid belt. It sits in the gap between the orbits of Mars and Jupiter, circling the Sun at roughly 2 to 3 times the Earth-Sun distance. Picture a huge, flattened ring of rock and metal, with millions of objects looping lazily around the Sun. It's the most famous band of debris in the solar system, and almost everything you think you know about it is probably wrong. Because in the movies, the asteroid belt is always packed wall to wall with tumbling boulders. Our hero throws the ship sideways, dodging rock after rock at top speed, sparks flying, just barely surviving. It's a fantastic scene. There's just one tiny problem with it. That is complete and utter nonsense. The real asteroid belt is almost unbelievably empty. The average gap between one asteroid and the next is hundreds of thousands, sometimes millions, of kilometers. To put that in perspective, that can be farther than the distance from the Earth to the Moon. Every single spacecraft we have ever flown straight through the belt has sailed across without so much as a scratch. Forget dodging rocks. Out there, the genuinely hard part would be finding the next rock at all. There are well over 1 million asteroids big enough for us to track, and probably countless smaller ones. And yet, here's the kicker. If you gathered up every last asteroid in the belt and squished them all together into one single ball, the whole thing would still weigh far less than our Moon. An absolutely enormous volume of empty space, sprinkled with just the tiniest pinch of rock. Quiz 1. The asteroid belt sits between which two planets? 1. Earth and Mars. 2. Mars and Jupiter. Or 3. Jupiter and Saturn. The answer is 2. The asteroid belt orbits between Mars and Jupiter. The undisputed king of the belt is a little world called Ceres. At about 940 kilometers across, this dwarf planet holds nearly a third of the entire belt's mass all by itself. It's big enough that its own gravity pulled it into a sphere. And under that battered gray surface, Ceres almost certainly hides a thick layer of water ice, and maybe, just maybe, a buried ocean of salty brine. We know all of this thanks to a NASA spacecraft called Dawn, which actually went into orbit around Ceres and studied it for years. And it spotted something eerie, strange, brilliant white spots, glowing on that dark surface like landing lights. For a while, nobody knew what they were. The answer turned out to be salt, the dried-out crust left behind by briny water seeping up from deep below. Ceres, it seems, is a bit of an ocean world in disguise. Number 2 in the belt is Vesta, a baby planet that never grew up. It got hot enough inside to melt and separate into layers, with a metal core and a rocky crust, exactly like a real planet. And then it simply stalled and froze that way. And here's the fun part. A surprising number of the meteorites that fall to Earth are actual chips knocked off of Vesta. so some shooting stars genuinely come with a return address. That same Little Dawn spacecraft orbited Vesta first, and then quietly fired up its engine and cruised all the way over to Ceres. That made it the first probe in history to orbit two completely separate worlds on a single mission. Not bad at all, for a trip to what most people had written off as a giant pile of space rubble. And we haven't just looked. We've gone and grabbed pieces to bring home. Japan's Hayabusa 2 and NASA's OSIRIS-RX both flew out to tiny asteroids, scooped up a handful of material, and rocketed it back to Earth. Why bother for a few spoonfuls of black dust? Because those particular asteroids are rich in carbon, water, and the chemical ingredients of life. We are, essentially, reading the recipe the solar system was cooked from. So why didn't all this rock simply clump together into one more planet? Blame the giant living right next door, Jupiter. Its overwhelming gravity has been stirring the pot for billions of years, speeding the asteroids up so violently that when they collide, they shatter each other apart instead of gently sticking together. This is a place that was always just one step away from becoming a planet, and Jupiter, the bully of the solar system, never once let it happen. And that's exactly what makes these rocks so precious. They are the leftover construction material from the birth of the solar system, 4.5 billion years ago, frozen in time, never reworked into a planet. Study them up close, and you are literally looking at what our entire neighborhood was made of before the planets even existed. They are fossils, fossils that still float. Quiz 2. What is the largest object in the asteroid belt? 1. Ceres, 2. Vesta, or 3. Eros? The answer is 1. Ceres, a dwarf planet about 940 kilometers across, holds nearly a third of the belt's mass. For now, just hold on to one simple idea. The belt is a world of rock. But as we keep traveling outward, away from the sun, things change. It gets colder and colder, and out past the orbit of Jupiter and Saturn, that rock slowly gives way to ice. So let's leave the inner solar system behind and head for the deep, dark, frozen frontier. Just past Neptune lies a second, far icier ring, the Kuiper Belt. Pluto lives out here, surrounded by thousands of frozen worlds left over from the dawn of the solar system. But notice something really important about it. The Kuiper Belt is still flat. It's a disk, lying in roughly the same plane as all the planets. Hold on to that detail, because in a few minutes, it is going to blow the whole story wide open. In fact, we've now visited one of these frozen worlds up close. After flying past Pluto, the New Horizons spacecraft pushed on another 1.5 billion kilometers to a tiny object called Arrokoth. It looked like two reddish snowballs gently stuck together, a perfectly preserved leftover from the moment planets were forming. It is, quite possibly, the most ancient, untouched thing humanity has ever seen. And every now and then, a visitor comes racing in from these cold frontiers, a comet. Now, a comet sounds romantic, but it's really just a dirty snowball, a loose lump of ice, dust, and grit. The magic only happens when it swings in close to the sun. The ice heats up and turns straight to gas. Dust comes streaming off in great jets, and the comet unfurls that gorgeous, glowing tail across the sky. And here's a lovely little trick that almost nobody knows. A comet's tail does not trail out behind it like the exhaust of a car. The tail always points away from the sun because it's being blown back by sunlight and the solar wind. Which means, on its long journey back out of the solar system, a comet actually flies tail first, as if it's driving the whole way home in reverse. Now, it turns out there are two completely different families of comets. The short-period ones, that loop back around every few years or decades, come from that nice flat Kuiper Belt we just visited. But then there are the truly long-period comets, the ones we might see only once in thousands, or even millions, of years. And when astronomers asked where those came from, The answer led somewhere far, far stranger. You probably know a few comets by name. Halley's Comet, faithfully sweeping past the Earth every 76 years. Hale-Bopp, which blazed across the night sky in 1997, so bright you could see it from a city, and which won't return for over 2,000 years. Or Comet Neowise back in 2020. Each one is a chunk of the cosmic deep freeze, paying us an extraordinarily rare visit. So astronomers carefully traced the paths of the long-period comets backward to see where they were coming from. And a flat disk, like the Kuiper Belt, simply could not explain what they found. These comets come plunging in from every direction at once, from straight above, from far below, from every side. There was only one possible explanation. Our solar system is not just a flat disk after all. Something huge and round must wrap all the way around it. That something is the Oort Cloud, a vast, spherical shell of icy bodies, thought to completely surround our solar system, like the peel wrapped around an orange. The planets, the asteroid belt, the Kuiper Belt, everything you've ever heard of, would all be buried deep, deep inside it, like a single seed at the very center of an enormous fruit. And how far out are we actually talking? Let's build it up. The Earth orbits at 1 unit of distance from the Sun. Neptune orbits at 30. But the Oort Cloud is thought to begin hundreds of times farther out than even Neptune, and its outer edge may reach all the way to about 1 light-year from the Sun. That is as much as a quarter, or even halfway, to the nearest star to our own. And inside that immense shell, drifting in the dark, there may be trillions of chunks of ice. Each one is perhaps the size of a mountain or a small city, and each one is separated from its nearest neighbor by tens of millions of kilometers of empty nothing. So even though there are trillions of them, the Oort Cloud is, at the same time, almost incomprehensibly vast and almost completely empty. Quiz 3. How far out does the Oort Cloud reach? 1. Just past Neptune. 2. About twice Pluto's distance. Or 3. About 1 light-year, partway to the nearest star. The answer is 3. The Oort Cloud may extend about 1 light-year out, a good fraction of the way to the nearest star. Out this far, the Sun is no longer really a sun at all. It would just be one especially bright star, lost among all the others scattered across the sky. There is no warmth out here. There is almost no light to speak of. There is only ice, drifting silently through an endless, frozen night that has lasted for billions of years. But now, I have to stop and be completely honest with you. No human being has ever actually seen the Oort Cloud. No telescope has ever taken its picture. No spacecraft has ever been anywhere near it. For now, the Oort Cloud is a hypothesis, an extremely clever and convincing idea, but one we've inferred entirely, indirectly, from the way those long-period comets behave. So why are scientists still so confident that it's out there? Because a giant round shell is by far the simplest, most natural way to explain comets falling inward from every possible direction. Back in 1950, a Dutch astronomer named Jan Oort worked through the math and proposed exactly this idea. The cloud has carried his name ever since, a whole region of space, named after a man who deduced it without ever seeing it. So where did this colossal shell even come from? The leading idea takes us back to the chaotic early solar system. As the giant planets, Jupiter, Saturn, Uranus, and Neptune, formed and shifted around, their immense gravity grabbed nearby lumps of ice and flung them violently outward, like a slingshot. Over billions of years, countless exiled ice balls were scattered and smeared out into one great, round cloud surrounding everything. And every so often, this delicate shell gets nudged from the outside. Maybe a distant star drifts a little too close. Maybe the sweeping gravity of the Milky Way galaxy itself gently tugs at it. Either way, one icy body somewhere slips loose from its lazy orbit, and begins the impossibly long fall back toward the distant sun. And tens of thousands of years later, that runaway becomes one of the great comets that we get to see. That, by the way, tells you just how loosely the Oort Cloud is held together. Out here, at the very edge, the sun's gravity has grown so faint and feeble that the combined gravity of the entire galaxy actually starts to matter. These distant, frozen comets are barely hanging on to our sun at all. A passing star is all it takes to set them free. And this leads to a genuinely spooky idea. Some scientists have wondered whether a passing star, every so often, could shake loose not just one comet, but a whole storm of them, a comet shower raining down on the inner solar system. A few have even speculated, and this is far from proven, that such showers might line up with some of the great mass extinctions in Earth's history. It's a controversial, fringe idea, but it's a haunting thought, that life and death on Earth might be nudged, ever so gently, from the very edge of the dark. So the next time you see a beautiful comet hanging silently in the night sky, stop and think about what you're actually looking at. It is a message from the very outermost edge of our solar system. A letter written in ancient ice that has been tens of thousands of years in the mail and is finally, just now, being delivered to your eyes. The Oort Cloud is also something more profound. It is the true border of the sun's kingdom. Cross it, and the gravity of other stars finally wins out over our own suns. Everything inside it belongs to our star. Everything beyond it belongs to the galaxy at large. This faint, invisible shell is, quite literally, the edge of the sun's country. And if a future probe ever set out to reach it, the trip would test the limits of human patience. Simply getting to the inner edge would take hundreds of years. Reaching the far edge would take tens of thousands. Even Voyager, the fastest, farthest object humanity has ever launched, won't fully clear the Oort Cloud for roughly 30,000 years. So, if you're planning the trip, pack a very, very big lunch. And here is a final thought to keep you up at night. In just the last few years, we've spotted objects passing straight through our solar system that didn't come from here at all. Visitors from other stars entirely, like the strange, cigar-shaped traveler we named Oumuamua, which means other stars almost certainly have their own Oort clouds, flinging out icy comets of their own. The galaxy, it seems, may be quietly trading frozen debris between the stars. And best of all, every bit of that ice out there is treasure. The Oort Cloud and the Kuiper Belt have stayed frozen, untouched, and unchanged for 4.5 billion years. Nothing has melted them. Nothing has reworked them. It's as if the exact moment of the solar system's birth has been carefully kept in a deep freeze, all this time, just waiting patiently for us to come out and read it. And these distant ices might turn out to be far more personal than you would ever guess. Long ago, when the Earth was young and hot and dry, comets and icy bodies may have rained down on it, delivering some of our planet's water, and perhaps even some of the raw chemical ingredients for life itself. If that idea is right, and it is still hotly debated, then a small part of you might literally be made from ice that drifted in from the very edge of the solar system. So step back and look at the whole picture. The asteroid belt is a vault of rock. The Oort Cloud is a vault of ice. One inner, one outer, two staggering storehouses, quietly preserving the entire origin story of how our solar system came to be. We spend all our time talking about the 8 planets. But the planets, it turns out, were never really the whole picture at all. We tend to picture the solar system as 8 planets going around the sun, and that's it. Done. But the real thing is thousands of times wider than that, ending in a vast, invisible shell of ice, drifting out there in the dark. Our home, our little corner of the galaxy, is far, far bigger than it ever looks in the textbooks. So somewhere out there, tonight, a single lonely chunk of ice in the Oort Cloud may be quietly beginning its long, slow fall back toward the sun. And tens of thousands of years from now, long after all of us are gone, it will come blazing across someone's night sky as a magnificent, brilliant comet. From the rocky belt between Mars and Jupiter, all the way out to the rim of the frozen shell a light year away, that was our journey to the true edge of the solar system. So the next time you happen to catch a shooting star or a comet hanging quietly in the sky, take a second and remember, it just might be a message sent from the very farthest reaches of our world. Thanks so much for watching all the way to the edge. If you enjoyed this trip, then come along on the next one, because believe me, we have still got a whole, vast, beautiful universe left to explore together. Until then, keep looking up, and I'll see you out there.